We are done with the first part of the question. The perpendicular height of the pyramid is 58.4. And then now the surface area of the frustum. The frustum has how many surfaces? You can see that it has this top surface, which is a rectangle, bottom rectangle, and the trapezia, two pairs of trapezia. One where dimensions are 24 centimeters by 18 centimeters, and also this one is 7.5 centimeters and 10 centimeters. Another information that you are given is that the slant edges of the frustum are equal, 15 centimeters each, 15 centimeters like that. So we will have to calculate the area, the external area of all these surfaces. So what we need to do, first of all, we can calculate the area of the rectangle, the upper part and the lower part. So we can start with the upper part. Upper rectangle, which is equal to area of a rectangle is gotten by length times width, which is 7.5 times 18, which will give us 7.5 times 18, that will give us 135 centimeters. To get the bottom part, rectangle, bottom rectangle, it is length, which is 24 centimeters by 10 centimeters, which is 240, or this centimeter squared, 240 centimeters squared, because it is area. So that is how we get to the area of the bottom. So what is remaining is the sides, and you are saying that you have two different trapezia. So another to calculate the area of these sides, there are two ways you can do. You can complete this triangle to the apex. You look for the area of this big triangle minus the area of the removed triangle. You will be left with this triangle here, I mean with this trapezium, like that. So that was your complete triangle. So you look for the area of the bigger triangle minus this area here, and what will be left is the area of the trapezium, this trapezium. You multiply by 2 because there is another one there. But this one you can do when you have the edges, these lined edges like this, which is possible to get, but also there is another way. So this is the first way that you can use. Another one is by using the formula of trapezium, whereby this side and these are parallel. You can take this to be A and this is B. You are given this side here, you may get right angle triangle. I mean you may get the perpendicular height, and the area will be I have A plus B multiplied by height. So that's another method. So you have two methods. You choose either. You can use this or this. So which one can we use? Maybe you can use this, the second method. You can use the second method. So 24 and this is 18, meaning that if you divide like this, you drop a perpendicular line there, you'll find that 24 minus 18, so the sum of these sides will be, because this length here will be the same as this from this point to this, because they are in line, perpendicular line, like that. So what is remaining is 6, which when you divide by 2, you get here 3, and this is 3. But remember, this is a right angle triangle, and we are told this is 15. So if this is 15 and this is 3, we can get this perpendicular height, which will act as the height of the trapezium. So to get the height, we know that height is equal to, using Pythagoras theorem, will be hypotenuse squared minus base squared, which is 3. I mean square root of this. Square root of, it will be square root of 15 squared minus 3 squared, if you apply Pythagoras theorem. Okay, so this will be 225 minus, so this will be 225 minus 9. So height will be equal to 14.7 centimeters. So that is the perpendicular height. So to get the area of the trapezium will be a half multiplied by A, which is 18 plus 24, multiplied by height, which is 14.7. And because you have another side which resembles this on the other side here, because still this 24 is equal to this length 24, and 18 here is the same as this other side, which is 18, because they are opposite, and this is a rectangle, the base is a rectangle, so you multiply it by 2. So that will be 18 plus 24, get that, multiplied by 14.7. So this will give us 617.4 centimeters squared. Centimeters squared. Okay, so we have gotten the area of the two trapezia, and then now to get the other one, this other one is like this. Where this side is 7.5 centimeters and this one is 10 centimeters. So if you do the same, you find that you will say 10 minus 7.5, which will give you 2.5. So the sum of this and this length here and this will be 2.5. So we divide by 2 to get the length of 1, which is 1.25. So this is 1.25 and this is still 15. Still 15. So we can get the perpendicular height there. Okay, so we do the same. Perpendicular height will be equal to square root of 15 squared minus 1.25 squared. So that will give us 14.95 centimeters. So that will give us 14.95 centimeters. And to get the area will be equal to a half multiplied by 7.5 plus 10 multiplied by the height, which is 14.95 times 2, because again they are 2. This one and the other side, and the other one which is on the opposite side. So what we will get will be 7.5 plus 10 centimeters times 14 point. Yeah, so that will be the area. So the area of this side plus the other one will be 261.63 centimeters. And now to get the total surface area will be equal to 135 plus 240 plus 617.4 plus 261.63. That will give us 135 plus 240 plus 617.4 plus 261.63. So that will give us 1254.03 centimeters squared. 1254.03 centimeters squared. So that is how we get the surface area of a solid of a pyramid frustum. Yeah, so you just look for the area of the surfaces, you add. And then now, lastly, the volume of the frustum. The volume of the frustum. So how do we get the volume of a frustum? So to get the volume of a frustum, volume of a frustum is equal to volume of the bigger pyramid minus volume of the removed pyramid, and this is the volume of the frustum. But we know that volume of a pyramid is equal to a third base area times height. So that is how we get the volume of a pyramid.